Honors Chemistry, and welcome to the Chapter 13 review, so I say Chapter 13, but really we're talking about Chapter 7 and 8 and 13 and like Chapter 5 and Chapter 6, and so, chemistry's cumulative, right? So anyway, first we're going to start by going over types of reactions, because I hope it's clear by now that you can't do any of the mole ratio based conversions if you can't write a chemical reaction. Now, we only need a chemical reaction if a chemical reaction is occurring, right? So we have to listen, or we have to read the question carefully for clues that tell us a chemical reaction is happening, right? We'll analyze some problems later, but one of the big things is going to be if your given and your goal are talking about different chemical compounds or different elements, yes? If your given and your goal are different chemical compounds or elements, you're probably looking at a chemical reaction, right? And note that that's different than what we talked about in previous chapters, where I want to talk about, like, for example, Na2SO4, and I want to talk about the sodium ions in Na2SO4, right? This is a piece versus the whole, which is a different relationship, yes? All right. Okay, now, so let's talk about some of our types. We have, going back, right, we have our precipitation reactions, where we're going to have two ionic compounds, right? That's what we're going to be looking for as our clue. And once we have two ionic compounds, we're going to switch our cations, right? Again, the formulas that we make are going to be based on Chapter 5 rules, right? What's the charge of the cation? What's the charge of the anion? The amount of positive needs to equal the amount of negative, right? And again, if looking back at the quiz or even the mixed practice, if much of what you're missing is how to write the formula, you need to spend time reviewing Chapter 5. So anyway, precipitation, that's going to be two ionic compounds. We will switch the cations, right? And then we're going to apply our solubility rules, right? And that's going to be another big thing. We have to make sure we know those, right? Another type of reaction that we talked about is a gas evolution reaction, where we're going to have an acid plus a carbonate or a bicarbonate or a sulfite or a bisulfite. And what that's going to produce is, it's going to produce H2O, CO2, and a salt. And by salt, we simply mean ionic compound. Here we're going to have H2O, SO2, and a salt. Again, that just means ionic compound, right? And the reason that happens, right, it's the same principle. We are still essentially just switching cations, right? But once we switch those cations, we have those intermediates, right? That H2SO3 or the H2CO3, which when we see those, we should immediately think, they're going to break down, yes? We also have our acid base, which can be also called our neutralization reactions. And don't forget, like your book goes into, right, gas evolution is really a type of neutralization. That's why they're covered together, right? But we're going to have an acid plus a base, right? And that's going to produce water and a salt. Again, salt just means ionic compound, right? Bases, what are those going to be? Right, those are our metal hydroxides. And let's see, what else? We also have our combustion, under the broad category of redox, we have combustion, right? Where combustion is often going to mean, in terms of wording, right, exposed to a flame or spark. And what that means is that it reacts with oxygen in the air, right? Whatever it is, right? Obviously, if it's a CH or a CHO compound, plus oxygen is going to give us CO2 and H2O, and the only tricky part is balancing, right? We also have our other redox types where we have, and don't forget, we originally said that redox was anytime we pretty much have elements, right? If we see elements on either side of the reaction, we can sort of gather that it's a type of redox. But we talked about a single displacement where we have an element plus a compound, right? And most often it's going to be an ionic compound, and the element will switch with whatever it's most similar to. the element will switch with whatever it is most similar to, right? Which means we'll look at the periodic table, and if the element is a metal, right, it's going to switch with whatever plays the cation, right? If the element is a non-metal, it will switch with the anion, right? So we just have to pay attention and look for those clues, right? In the mixed practice, we also talked about a simple decomposition, right? Wherein if we have only one reactant, and if that one reactant is made of two elements, right, it'll just produce. So it's going to break down, it's also called decompose, into its elements, right? And if we think back to the lab, that chapter 7 lab, some of the keywords we would look for is, right, heated. Hey, that's terrible. Heated, right? Which is different than exposed to a flame, right? This is where we would put something in a Bunsen burner, put something in a beaker, right? And heat it not in direct contact. All right, so this would be a refresher on the types of reactions that we've covered so far. And again, you have to be able to write these in order to do everything else, which is why they're important, right? And this also obviously ties back into being able to write names, because you can't write the reactions if you can't write the names, right? From what I saw on the quiz, I do think that a lot of the reactions seem pretty good. The gas evolution is one that most people should probably study a little bit. But for most people, it is chapter 5 stuff. So make sure that's on the list of things to review in preparation for the test. All right. Thank you for listening. Stay tuned in the next one where we go over a review of the conversion factors we know to date. All right. Be good. Have a good day, and I'll see you soon. Bye.